Hello everyone, welcome back to pressure. Now for this topic, we are going to explore how we're going to use the idea of pressure, especially the formula that we have learned previously, pressure equals force over area, and apply in our daily life. Now what I have here is actually a hydraulic system. It may not be very obvious to you, but the hydraulic system is quite commonly used in our everyday life, especially some doors where some people open the door and if you don't close back the door will actually slam. But if you look at the structure above the door, there's this hydraulic system where it slowly let the door close by itself. So this is one very simple application of hydraulic system. The other hydraulic system, like for instance in a car repair workshop, how the mechanics lift up the car so that they can repair the underneath of a car. So for this, we are going to use this example of a hydraulic system lifting a car to explore how hydraulic system is used in our everyday life and how we're going to use pressure to explain how the hydraulic system works. For this example I have here on screen, what we have here is a simple hydraulic system. It's a very simple system. Now you notice that on your left, your piston is quite small, and on your right there's a large piston. Now that's because on your left is where you apply the force, and on the right is where you put the load. Now on the left is where when you apply a force, F1, and you notice that the cross-sectional area of the piston is actually relatively small. We call them A1. Now you look on your right, what happens is that when you actually put a load as shown here, and your load, you will need force F2 to push it up. And you notice that the piston on the right is actually relatively large, so we let the area be A2. Now before I proceed any further, before I proceed any further to a theoretical part, now in this hydraulic system what we have is actually a small force can lift up a very large load. I say again, the small force can actually lift up a very large load in this hydraulic system, and that's why it's very useful for us. Now how is this possible? The hydraulic system works by using liquid under pressure. So when we go back to this system, what we have here is the green interface that you see is actually commonly oil, but actually is liquid. Oil is preferred because most hydraulic systems are made of metal. So water is not preferred because water will cause metal to rust. Hence oil is usually a preferred form of liquid used in hydraulic system. And oil is actually more lubricated. So well, when I talk about lubrication, so that means it should give you a sensing of there should be less energy loss due to friction. So that will make a hydraulic system actually more efficient. So the hydraulic system works by using liquid under pressure, and that means when I apply a force F1, the pressure is exerted to F2. Sorry, the pressure is exerted from the small piston to the large piston. So in order for the pressure to transmit this way, the liquids must be incompressible. That's why a liquid is preferred. It must be incompressible. So the question you should be asking yourself is, what if gas is used. I'll leave it to you to discuss with your friends, okay, how the hydraulic system will be affected if gas is used. And next, the other second property of liquid that is preferred is because when a pressure is applied to an enclosed liquid, right, the pressure is transmitted equally to all parts of the liquid. Okay, this is a very, very important factor when you want to explain how hydraulic system works. Notice the word is the pressure is transmitted equally to all parts of the liquid. So that means your force can be in any direction, right? But the pressure will be the same, transmitted equally to all parts of the liquid. So we're going to start by this example here. Now, as mentioned, in here is oil, right? Now, if I were to exert a force F1 on this cross-sectional A1, cross-sectional area A1, and if I have a load here, it's going to push up with a force F2, and the cross-sectional area is A2. Now, because pressure is transmitted equally to all parts of the liquid, we can say that we'll name this region X and we'll name this region Y. Pressure at X equals pressure at Y. Right, so this sounds familiar. Okay, it goes back to your principle of moments, it goes back to your conservation of energy. Right, in principle of moments, anti-clockwise movement equals clockwise movement. And the conservation of energy, total energy at one point equals total energy at another point. So the same idea to model your solution is right here. Pressure at X equals pressure at Y. We start off here. And from here, we have pressure at X will be F1 over A1. Pressure at Y will be F2 over A2. Since both pressures are equal, and A2 is bigger than A1, therefore F2 has to be greater than F1. And because of this, a small force can be used to lift a heavy load. So in another way, we can also call this a force magnifier. Right, a force magnifier. A small force can be used to amplify. The small force is amplified to lift a much heavier load. And from here, if you still need to review the video again, you can rewind back. Otherwise, we'll proceed on to problem solving.